That's a really strange amount of students. Okay, you know what I should do when I'm streaming? I should have gone back to this, as it might just, but it's not, I don't know. Sometimes has this way of, anyway, so here we go. Share screen, let's share the screen. Okay, so we're looking at business intelligence today. There are a number of objectives. We are going to be talking about data management and business intelligence and data mining and all of that. So as you probably already know, there are more and more data that is for all businesses. So this particular example on the screen is a little bit unusual for us here in Jamaica. So it's about I think this is a Charlotte Hornets. Is that football? It's an American team, and they actually keep a lot of data. Oh, I should just admit all automatically, right? They keep a lot of data, and they had outdated data technology, and so because of that, they put in place a number of things to track their fans with a data warehouse so that they could do better customer analysis and make business decisions that would essentially increase their profitability. So everybody in this class, I hope, knows what a database is. So they're either a set of manual files or computerized files that has records. And so any database would have a number of entities about all the categories.
That is a database.
No, man, it's a base of data. Right? So what is a
Why am I having people in the class?
Again,
Somebody's trying to say what a database is? I'm hearing some things in the background. Did somebody have a comment that they wanted to make about databases? Oh, I guess not. Right, so you know the database has several entities, and each of those entities has a number of attributes. So this one here on the screen is where you have suppliers and parts, and then each supplier would have things like name, address, as well as all the parts that they supply. So one supplier would have a one-to-many relationship to parts, because one supplier usually sells many kinds of goods that are called parts. And then the part would have probably a unique ID and a description, a unit price, and that supplier that is linked. So some databases are relational, where there is a one-to-one, one-to-many, or many-to-many relationship between all the entities in that database. And when you do a database class, you will learn how to create a relational database. In a good relational database, you actually have a field that uniquely identifies each record. So it could be for persons in society, that would be in Jamaica, the TRN. For students, it would be the ID. For parts, it might be a part number. The point is, in any good, well-designed database, there will be some primary key, and often there might be a secondary key. For students would not only have a student ID, a secondary key that uniquely identifies students would be TRN, since I think every one of you, based on how the government has set things up, would also have a TRN. So I'm just going to assume that everybody here has done database management systems, because it's required for certainly for the BSc computing degree. So, and even in IT, you would have learned some basics about a database. So we're not going to go over basics about a database. We're just going. Oh, people keep joining class. People keep joining class, not muted. And I'm trying to mute and it's not happening. How do my older person mute themselves? How do I do this so that people don't come in muted? Yes, right. So you have, like, here's a set of suppliers and their names and the like. And these are the parts that these particular supplier sells. This is the part number, etc. And this is the suppliers who sell these parts. So you can establish relationships between, as I said before, it could be one-to-one, one-to-many, or many-to-many, depending on what is happening in the real world. One-to-many are the most common kinds of relationships. So like in a typical Western marriage, it's a one-to-one relationship, one wife to one husband. But it can actually be one-to-many in other situations. But let's just leave it alone. In a university, there's one university and many students. But with faculties and students, there are many faculties and many students. So that's a many-to-many relationship. So this is us showing the entity relationship diagram. We know that there are ways to normalize a database so that it is created so that the relationships between the various tables that have the records are consistent. This is not the class where we're going to teach you how to do normalization, but you should know that this is important if you're establishing a database as a business owner or somebody in charge of some section of a business that's having a database. On a side note, some years ago, I went to a government agency and I was literally unshocked. So maybe I should just go back right here or even back to the screen where I had, it's not me, this is a shape from the textbook for the class, primary key. So government agency in Jamaica, very important one. There was a department and they were recording important data. And I was there on an internship for during the summer as part of a degree program. And somebody came to me because they knew I worked in fact, I was there not even for computing, but they came to me because they knew that I was in computing. And so when they're saying they wanted this report. So when I said, well, I said, I need to come and look at what you actually have. The long and short of everything is that they had no primary key. And so because they had no primary key and plus the data was all in Word, so then you have it in a spreadsheet. So they actually had the data in Word, no primary key stored. It would have been such a difficult, tedious process to get it even into, say, a spreadsheet so that they could have done the analysis. They actually had stored it in a spreadsheet program. Then we'd have some hope to get it into a regular relational database. I just said to them that the amount of time it would take, I suggest that as of today, they need to find a way to store the data, at least in a spreadsheet, but preferably in any kind of electronic database so that they could get the reports that they wanted. So saying all of this, this is not even necessarily the case that people are using electronic databases when they are important. So, and then after you actually have the electronic databases, if you have a lot of data, then you want to make sure that the database is designed so it is normalized and it is created so that it follows basic referential integrity rules. If you have done database management, you know what I'm talking about. Otherwise, when you do it, whether at UTech or just go online and learn it on your own, there's lots of YouTube videos to figure out how that works. So this is a bunch of database. So we have different entities, the part, the line item, the orders, and the supplier, and these have a relationship. So obviously an order, you can just talk about the order succinctly by just having what the order and the part and the quantity. And then you can just talk about orders in terms of the particular order number here, 3502 is on this date. I mean, they could have put this here, but basically all of this relational database would basically mean that you don't need to have unnecessary data, redundant data being stored in the database. So you can have relationships. So here the supplier provides parts and the order has a number of line items, which each line item has a part. So basically we have a database management system, which is a software program. So a database doesn't mean that it is a software program. It's just a record, which could be manual.
Excuse me, Miss.
Yes?
Miss, could you let Joshua in, please?
If I could let Joshua in, all right, I'll look. I don't see, oh, okay, oh yes, there are some people. Oh, these people came in late. I've been letting in people, but it's difficult to be giving a lecture and letting in people. But yes, I didn't purposely not letting people. Right. So a database is technically just a set of records about anything. And the database management system is a software that actually stores that information. So you can technically think about the logical view, which is how the end users, which don't only have to be like, end users can be people in an organization who are managers. They don't have to be customers. It depends on how your database is going to be used as to who are the database managers. Sometimes they actually are customers if there is some kind of data that customers are actually going to end up seeing. Like for example, you're on Amazon, you ordered a product, so obviously the customer wants to see that, be able to track like what is happening with the order. So there's sometimes some part of the data is actually shown to the customer. So you have the logical view, which is about what the data sees, and then the physical view, which is how you actually structure and organize it. And there's a whole lot of different kinds of software programs that are able to store database systems. And so here we have a data management system that has benefits and payroll view and the human resource, and different people would see different parts of the system because the benefits would be seen by the employees and the payroll would be seen by the people in the payroll system, possibly by the employees too. I'm trying to think, this is what? Life, pension, health. So the payroll view would be both the employees and the people in the payroll system. So in terms of a relational database, you have a number of different operations, selecting records from the database, joining tables together, and actually creating reports, which are subsets of stuff from the database. And you can look through this at your own leisure, because as far as I see this, the first part of this presentation is basically what you would do in database management. And so we're just going to skip it. I mean, we're not skipping it, but we're skipping it. So you should know that in a, boy, people all come into class very late. Yes. So in a database management system, you're going to have the a data definition for every single entity and record in the not record, every field. So every entity and field in the data should have a specific definition, and it'd be good to have a data dictionary where you actually store those definitions and their characteristics, so there's no confusion at some point if somebody leaves the organization. And then there are ways to query from that data. And one of the popular ways to query from the data is to use structured query language and other kinds of query building tools so that you can essentially create reports that is relevant. So this is showing Microsoft Access. We're not going to worry about that, right? This is an example of a SQL query, which is showing this is structured query language. And this is showing that from a particular part, we're looking for where the supplier number and the part number is 137 or 150. We're going to find all the suppliers that give either part number 137 or 150. So you can do the same thing with Microsoft Access and see here, you're looking for part, the suppliers for parts that are either 137 or 150. And the point is you can do that in many other software programs. So there are also databases that are non-relational, and let's not worry about that today, but they are used extensively as well today. There are also databases that are on the cloud or distributed, and if they're on the cloud, they're typically, well, sometimes they can be free, but they're typically, if there's a lot of data, there's going to be some price associated, because I presume everybody here understands that things on the cloud are stored on servers, and the individual servers do cost money, as in their computers with a lot of data. So essentially, usually when you go beyond a certain amount of space, you have to pay for that storage. And cloud databases tend to appeal to smaller businesses because they don't have to take on issues in terms of buying and maintaining and being concerned about privacy and security. If they can actually pay somebody else to deal with those matters, then they can just essentially get to the business of doing their business and not worrying about having experts in the inside as well as all the technology inside to handle that well. So for example, you could use Amazon's relational database service as an example. And then there are others. So Oracle, for example, is a good database, and there are many others. And then we can also use distributed databases where the data is actually stored in multiple physical locations. And apparently Google has one such one. So at the end of it, we all know already that there are database management systems. And perhaps you already know, so people who are in the know in this class would know that for quite a while now, there's been so much data being stored from businesses and educational institutions and even nonprofits now, that we have lots of possibilities of what can we do with all that data. So some of the challenges are that it's a lot of volume, a lot of variety of data, and it's all coming very, very fast. It takes up a lot of space, but even though there's all this data, it has the potential benefits, especially from a business point of view. So if a business decides to look at, do analysis to look for patterns, they can find patterns in the customer behavior. So the story from the textbooks that I'll never ever forget because it's really so bizarre and this really happened, is that there is a story that a male came into a teenager offering something like maybe diapers for a discount, and the father of the teenager went to the store that sent this physical mail, quite distraught. How dare they do this? And as it turned out, trying to remember I'm actually look this up in the textbook to be sure how it's going on, but it turned out the teenager did not know that she was pregnant. So certainly father didn't know she was pregnant. But the point is, based on the pattern of what she was doing, they had made some guesses, and then they had sent out promotions based on the patterns, because customers that are like this act like this, and apparently some of those things are predicting things that are unexpected. So I know for all the years I've been online, so perhaps especially the last as much as 10 years, but certainly the last 5 years, I find that the ways in which the ads online, the YouTube ads for me are not that good. The only thing on YouTube that is really good is YouTube predicts what I want to watch fairly well. I would say 90% of what they predict I want to watch is good, but their ads for me, for the most part, are not so good. But Google, I think because I've been using Google for so long, Google tends to, if I do even pay anything that they have mine, I don't know, since Google owns YouTube, I'm kind of confused why they don't have good ads on YouTube for me. But whether it's Amazon or say google.com itself, whatever is there in my experience tends to really mirror, because they have so much data about me. And if you read, and that's the case for almost everybody. And so because they have so much data about so many people, they tend to be really good at predicting your own behavior, because they see patterns on people's behavior, and people tend to be like each other people. So because we have these big data sets, we can actually learn lots of things. With weather patterns, a little bit more complicated, because still, up to now, as far as I know, meteorologists still are not able to completely understand weather, meaning predict, as in, you see anybody accurately predicting exactly when a hurricane is going to hit, and tornadoes are even worse. Tornadoes don't hit Jamaica, or earthquakes, all of that. But the point is, there's so many big data sets, there's better ways to predict now, because we have these data sets. So all this requires new technologies and tools. So in that context, there is the opportunity for business intelligence infrastructure, which includes data warehouses, data marts, Hadoop, in-memory computing, and various analytical platforms. So a data warehouse is a database that stores data that is of interest to decision makers. It consolidates the data across various data sets, both transactional. Remember when we talked earlier weeks ago about the transactional processing systems? So that would be a transactional database. Remember, transactional processing systems are not only financial, it can be any kind of record that's important for business. So for example, hiring an employee is a transaction, firing an employee is a transaction, paying somebody money is also a transaction, like paying employee. But every single thing that's recorded is a transaction. But there are so many other operational matters that are also recorded. All of those things can be consolidated in one database. And then there are data marts, which are consolidation of various data warehouses so that you can look at specific population of users. So could be that the business is looking at adolescents separate from elderly, separate from whichever other group, so that you can see trends in that group so that you can market to that group. Because essentially, if you're able both to market and to have customer relationship management systems that are able to cater to people who buy, not just market to them, because the whole marketing process starts with a invitation and then it continues with continuing to please that customer and prospective customer throughout their life cycle until they decide that they're going to leave. So open source, Hadoop is an open source software framework for big data, and it can break the data task into sub-problems. So it is actually separated into many different processing across several computers. So it's easier to analyze. In-memory computing is where you use the RAM for data storage, and that eliminates bottlenecks in retrieving and reading data. So that tends to lead to shorter query response time, because we all know, I hope, that when you store stuff on if data is on the hard drive or on the cloud, but not in RAM, once the computer is trying to retrieve data, it's going to take a whole lot longer. If it's in RAM, so the bigger RAM is, the processing of that data is going to be faster. Loads in RAM faster. Thanks for the more. Right. And then you're going to be able to, if you have in-memory computing, that's going to be useful if you also couple it with high-end processors and multi-core processing so that the processing costs are lower. And why do we want to lower processing costs? Because if you're having big data, it's a whole heap of processing that needs to take place if what you want to do is to analyze that data for business intelligence, which is the topic of this lecture. So there are a number of analytical platforms. So those include pre-configured hardware and software systems that are designed for query processing and analytics. And you could use either relational or non-relational technology to analyze those large data sets, as we just mentioned, including in-memory systems and NoSQL database management software and data lakes. So one example would be the IBM Pure Data System for Analytics that integrates a database with a server and storage components in order to enable that analytical platform for business intelligence. So here is one, like a big picture example of the infrastructure required for business intelligence. So you're going to have the power users who are going to typically be the senior executives and maybe even upper middle managers that are going to be making queries, reports, looking for online analytical processing and data mining because they're making big decisions. But in addition to that, there are going to be other people in the business that will be looking at queries, reports, and dashboards, and essentially need to set the whole thing up so that so that you can essentially get the data that you need to all the users in the business. And in the best companies that are large, you set it up so that perhaps all employees that can be trusted have access to some data. Because if it is that you can actually get employees to co-op to make the business better, if they can have access to data, they can make great suggestions to the business about how the business can operate better. You know, maybe there's more ways than this, but two ways I can think of how employees can make businesses or even institutions like UTech better. One is in their own experience, they can see something and say, oh, here's a good idea. But also if they have access to the overall data, they can say, oh, but this is a pattern. And then based on that, this is my good idea. So it is really useful to have data insofar as, by the way, remember, this is not all data will be with everybody. So for example, in any company, you would not have everybody having access to the HR files, like as how much people are getting paid. So with all of these databases, it would be dependent on what is relevant for decision making. Right, so you have all of this so that you can extract and make it available in different ways to different members of the team. So let's forget about that. That's a particular scenario. I want to leave that alone. So in terms of analytical tools, once you have this data together, we're using software for querying the database and reporting, doing online analytical processing, which is a multidimensional data analysis, so that you can mine the data that is stored in the data marks and etc. So what is online analytical processing, I'm saying that wrong, is where you're doing data analysis of multiple dimensions of that is stored in the database. So you could, for example, let's take something simple like a company that's a retail store, and they have stored obviously products, pricing, cost, region, and time period. You may want to know, so whether you may want to know, let's take Jamaica, you may want to know how the urban areas compared to the rural areas. You may actually want to know how northern parts of Jamaica compared to the southern parts. Whatever you want to know, you might want to know in terms of different months of the year as it changes. You know, for example, some businesses, Christmas is as in Christmas, you know, or the few months right before Christmas, maybe a month before is the time that has the most sales. But maybe if you're a business that is selling weight loss, it would be probably January, February when people are making New Year's resolution. But you can look at all of those kinds of things over more than one dimension of the business to see if you can use that to improve how your business is operating. I mean, you could even use online analytical processing for crime analysis. I think in Jamaica we definitely need that. We need something. I mean, sorry, that alone won't be enough to solve the crime in Jamaica, but certainly I think we need some analytical thinking about the crime scenario. So by doing this, we can enable the users to get answers to any ad hoc question they have really fast if you have online analytical processing. So as an example here, if you categorize the company, if it had east, west, and central sales, and they were selling nuts, bolts, washers, and screws, then we can actually have data for all of this. So this is a multi-dimensional data model, and so then you'll be able to basically show this data and cut this data in different ways. So you could see it by data visualization as well as by detailed numerical form. So data mining is essentially just looking for patterns and relationships in databases so that you can, if they're not always rules, but if there are patterns, then you can say, these are the rules that are likely to still be true in the future. So the kinds of information you can obtain from data mining includes associations, sequences, so association relations, sequences, so association linked to a single event, like, so I don't know, what's a single event? So a single event would be election. So in elections, do company sales go up or down? Or in the Olympics, those crime in Jamaica go up and down, because you guys don't know it goes down in general. People are so happy with what's happening. The people who are the criminals, they start watching sports and they kind of forget to do any break-ins that reduces at that time. Sequences events linked over time. So there's been some interest as to whether Olympics and other sporting events, people who watch, do they become more active? If you wanted to know that was the case and you were a sporting goods company, you could get that data and see if you could link how you sell your products with those kind of patterns, and then tie in your advertisements with those kind of patterns. Classifications, patterns describing a group an item belongs to. So like since I just mentioned sporting goods stores, they would sell different kinds of things. So they not only sell clothing, they also sell sporting goods. Like I bought in sporting goods stores shoes. So I bought like clothes, shoes, and equipment. And so you might want to now look at patterns for different kind of things. Is there differences between how shoes are sold over the time, how clothing, as in sporting apparel and sporting equipment? Are there differences in how those sell over time? And maybe, back to clustering. Is there some groupings that nobody noticed was actually a pattern? So maybe there actually is a link between, I'm not sure. Let's get out of sporting goods, but that doesn't sell very much. Somebody has a suggestion? Like eggs in December? Yeah, that would be an example. So if people buy more eggs in December, like maybe we think they would buy more in Easter, but not in Jamaica. Because like in the US, people like are into Easter eggs. But yeah, so if in Jamaica people were buying more eggs, I'd be like, huh? Apart from egg wong, or a lot of baking. Yeah, but then if it's a lot of baking, oh, that's definitely then that is not a, then if it's baking, then that is to be expected. Sorry, to be clear, what is not expected is, sorry, I never thought of that. It's something that you're not going to expect. So I never thought of that. Yeah, I was thinking of eggnog, people that they in some parts of the world they drink eggnog at Christmas. I've never had it and I just feel like I don't want to have it, but maybe I'm wrong. Yeah, but the point is, if you actually have a lot of data on your sales, you may find patterns that you don't expect. So let's go to beer. You may think that only men buy beer, but you might find out that women age 50 to 59 buy a lot of beer in Jamaica. You never expected it if you did it, and then you might say, oh, okay, let's do some marketing for the light beers to women of that age. Whatever, I'm just making up something that I'm thinking that sounds unlikely. So, but you wouldn't be expecting that. At least I wouldn't. Would you? Would anybody here be expecting that? That's what I mean by finding things that we're not. But I think in Jamaica we're expecting more baking in December, because that's what happens already. And then forecasting now is to say, based on the data we have, can we come up with some predictions? And then of course we would obviously want to follow that to see if the forecasts are correct. And so what we actually have in terms of text is a lot of unstructured data that is actually useful. And so there are ways to actually mine the text to see if we can find patterns. And we can do we can choose to do sentiment analysis using online text comments. So for example, Twitter, there's a lot of research using sentiment analysis on Twitter. And since Twitter is actually quite popular in Jamaica, I know it's not the highest social media use, but apparently a lot of news breaks on Twitter. I don't have an active Twitter. I have a account, but it's not active. And so if you want to find out what is happening and how people felt about news in Jamaica, that would be a good, like, and when I said news, if it is that you are a business and there is information, so maybe you can ask Twitter for downloading data that's public, because Twitter is public. So you could choose to do some analysis of things related to your to your business if that's on Twitter. Not sure what would it be right now, what business are we thinking of. I'm not sure, but certainly let's take the stock market. I would think that from time to time people might tweet about that, maybe not. So I'm going back all the way to the time when, you know, the Jamaican stock market was actually #1 in the world in terms of returns about 2 or 3 years ago, or maybe 3 years ago, before COVID. And I think when that news came out, I would have thought, I wasn't looking at it, there might have been a whole lot of tweets on that. How did the stock market in Jamaica use that to say, could we actually increase like our sales abroad 2019? Or there are people who are in. Actually, I would say I was right. I said 2 or 3 years ago. All right, Joshua, I'm going to take your say so for it. Did the tourist board actually do any sentiment analysis and then use that data to, you know, improve their business? In addition to that, we can mine data from the web. Clearly, we can look at the customer behavior, like what people are doing by, you know, taking the cookies and evaluating what they're doing on our websites to improve our marketing. We can mine the content of other people's websites to see what we use on our website, and we can essentially look at the websites that we create for our business to see what structures of our websites work, and then look at how it is used and do all of that to see how can we improve websites so that we can essentially successfully market to our prospective and existing customer base. And then on the web, on our websites, we can actually have databases that are available to customers and partners. So middleware, which is software that is, as the word implies, literally between two kinds of software. You can use web servers, application servers, database servers that can store information that will be useful to essentially then mine that data to see if you can provide that data to customers so that they will be happier. I mean, let's take a simple one I overuse. So I find that there's many things wrong with Amazon, but one of the things that's not Amazon is how they cater to customers. So I have a coworker who thinks that Amazon is evil because of how they do things that perhaps, like for example, like one thing that's not so good about them is how they treat their employees. But in terms of how they have found a way to automate and manage the customer relationship process, they do it really well. And they basically have all these kind of servers doing that pretty well. And then there are ways to integrate databases with partners. So since I was using Amazon, you can store information about the affiliates and how people are coming in, like and making purchases through our affiliate, and then providing small incentives to do that. If you do that well, people coming in making noise. If you do that well, you can essentially have effective website. So here we have a web server, an application server, and database store. And so you can having a good interaction of the client with your web browser. It is important as a company to establish an information policy that states the rules for using data information in an organization. There should be somebody in charge of data administration because the data can be the heart. So, you know, for more and more businesses these days, data is the business. So if you think about Google, Facebook, and a lot of online businesses, literally it is the data that's the business, nothing else. And so in that context, but even in businesses where the data is not the business, it is so important to have an information policy and to manage that whole process. And so in that context, it's super critical to have good data quality, because if not, it can impede the customer relationship management process. And so it's important not to have redundant or inconsistent data. It's good to have one enterprise resource planning system that will reduce the likelihood of input errors. So where possible, people will be entering the data straight into the computer system, not scanning in manual files and the like. There should be, in addition to that, a audit where once it is a critical part of the business, auditing the data quality. Let's take a bank. All financial institutions, not just a bank, all financial institutions, which include insurance companies and government agencies that have financial records, would need to have an excellent quality audit of their financial records. But really, most businesses, data quality is pretty important. And so as they audit, they would need to cleanse the data to make sure it's accurate. Can you imagine that there's actually been research? I have not seen the latest 2021 data, but often police don't have always accurate data. They might store the name of a criminal and it's not distinct, it's not unique. That's why things like the tier in what they call it in the US, whatever, Social Security is so important when you're going to store criminal records, because you don't want to mix up the people, or in credit records, because often by having an incorrect crime or credit data, it can adversely impact somebody for a long time. It can be quite a trick to clean up. So quality and cleansing is so important. So this is really it. So will information help your career? Well, it all depends, but I would think that the big question really is, if you use it well, it could.